All right. Hi, everyone. Thanks for coming to the, God, what is it now? October 2022 Reactor call. You'll see a couple new faces versus last time in here. So we have Zishan, who's joined the team in the past few weeks, I guess, and is also in the Reactor. We may have Blaine show up as well, who's also doing Reactor work as well. And actually, if somebody wants to go and like poke him with a little stick, it could also be interesting to get him in here to talk about some IPVM experiments. So in classic Fission fashion, this means that instead of having several people focused on one thing, we decided to have several people focused on many things. So stuff that's already been in the Reactor going back quite some time already, but now we just have more brains on them. So yes, of course, dialogue is continuing on. Quinn will be able to speak to some of that. We are making progress with car mirror and have some early thoughts that I think would be interesting. Zishan and I can talk through on carpool as well. And we're actually finding it's yet another one of those cases, just like with UCAN, where it's like, it's this tiny little part of our system. We're just solving a problem for us. Oh no, everybody uses this thing, okay? And IPVM, which is a distributed computation substrate that Blaine has been doing some experimenting with, early explorations on, and I've been doing some writing about as well. So to kind of kick things off, on that list, Quinn, you said you had some stuff you want to chat about for dialogue.
Yeah, so I'm not sure how much detail we want to go into all of it, but been really getting back into spec writing since getting back from the team retreat about 2 weeks ago. And my focus this week has been on really getting the details clear in terms of what's required to compile from data log to the differential data flow stuff. So I'm doing that in terms of relational algebra, obviously, and basically start with the data log, compile to relational algebra, and then go from there to DVSP. So I've just been getting all of the precise details down in terms of where we need to integrate, where we differentiate, where we tie different streams together, and so on. If we want, I can walk through what the compilation of something simple like transitive closure looks like, just on paper, but I don't know how much time I want to spend on that. It won't be super new compared to what we've seen before, but it might be interesting to people if they want to see what this relationship between SQL and data log looks like there.
Yeah, and also to give you one more prompt as well, we went to the High Performance Transaction Systems conference week before last week, I don't know, however time works, last week. And Quinn gave a presentation about how we can view this kind of a system as a postmodern database, and sort of the philosophical underpinnings of that, and ended up having some really interesting discussions. And I realize I'm putting her a bit on the spot. We're in bullet points, because I know we spent 3 days talking to people. What were some of the big takeaways there?
Yeah, so I think the biggest one was kind of the difference in scale that we're dealing with in the database world, and that people kind of fall into two camps right now. Either you're someone like AWS who has the capital to literally build your own hardware to build these giant supercomputers that can process data for 7 billion people, or you're not AWS and you either can't afford servers whatsoever, or you're collecting a bunch of venture capital and then immediately handing it all over to someone like AWS to run your servers for you. So we saw a lot of interest in the use of local first software for those smaller scale deployments that allow people to offset a lot of those hosting costs, a lot of those compute costs, and move things onto consumer devices. And also a lot of excitement around like operational savings in terms of what's involved in running and maintaining and keeping an eye on those services and so on. People are very excited about the privacy and security implications of what we're talking about. And Brooke and I do actually have some exciting results on the cryptography side of dialogue. I can walk through those a little bit today too. I guess the other main point of my talk, the postmodern systems one, was about this idea of having kind of intersubjective software is what I've been calling it, where the meaning of a piece of data depends on the context that it appears in collaboration with the other devices and servers and nodes and so on that are communicating over that data. So in our world, that means having different interpretations of CRDTs that are imposed on the data at query time. I've talked about this a little bit before in past Reactor sessions. This shows up in things like the decentralized social media cases where you have overlays for like fact checking and things like that. But this seemed to be a fairly novel idea among basically everyone at the conference. And a lot of people are really excited to see what that looks like in practice and where else it might show up. There was a lot of excitement about where that sort of thing might show up in helping, again, these like smaller application deployments that are meant to service and help users across much more disparate groups throughout the world, rather than kind of targeting this like average user that doesn't actually exist, but that we kind of build the web for today.
Yeah, the one thing that I'll add in on there too is we had, I would say, 2 reactions, because really most of almost all the other presentations were about scale and speed, big, huge systems, right? Google, Microsoft, Amazon, right? Like big systems. First reaction is, that sounds interesting, tell me more. Oh, wow, that changes a lot of things. That's kind of an underexplored space. That's really interesting, tell me more, and having really good discussions. And the other one was, you're all idiots. That's not how databases work.
And philosophy is useless.
and philosophy is useless, yeah, exactly. It was like, okay, cool. I consider that a win, because if you just have everybody standing around agreeing with you, right? Maybe you haven't said enough. And the fact that we were kind of getting the hackles up on a few people was interesting. I'll also say that it was, I mean, I had a blast at this thing. It was great. But also some of the Q&As were like, we'll call them pointed. And so I was literally seeing the popcorn at one point, like a bag of popcorn, being like, this is fantastic. So I had a great time at this thing. Mm-hmm. And I think we also walked away with some potential collaborators across a few different projects, which is really interesting, and not just for dialogue, but also across IPVM and talking to them about things like UCAN and WinFS and these other systems too, which was pretty interesting. So anyhow, sorry, I thought I was going to say one sentence, then I just sort of like rambled. So maybe if we. I think probably, Quinn, your stuff might end up taking the largest section because it's the furthest along. I might, and sorry, Blaine, I had sort of given an agenda right off the top. Did you want to talk a little bit briefly about the very, very early explorations, or this plan in IPVM space? And it can be, we're totally unscripted, it's totally fine.
Oh, no, okay. So announcements just went out. I have just joined Fission 2 weeks ago. So maybe 3 weeks, I don't know, what is time anyways. So I'm starting to look at building out some prototypes of what IPVM might look like. And so it's really just, how do we execute stuff, but not in like a theoretical space, but like in an actual practice sort of way. Like, can we get things to execute? So it'll look very hello world at first. I'm not sure how much detail is valuable here. I've just been reading a ton, an absolute ton. I think I've got like the 50,000 foot view, and there's sort of, it's an interesting space because there's a bunch of stuff that's not built yet, but there's also a lot of thinking that I don't want to like duplicate badly. So it's finding that balance.
So for IPVM, because obviously this is a very large project and there's not enough writing about that, which is entirely on me. So I've been doing a bunch of writing that I'll get post publicly. My hope is literally by the end of the week, so we'll call it tomorrow. Post maybe half or not quite half done, and to kind of get that project reoriented. But in the meantime, Blaine is going to start with literally like, doesn't have to be a bash script, but I keep calling it like a bash script that can just like grab WASM out of IPFS, pull that down, apply arguments to it, take the output, dump that back into IPFS, and then pipeline that as part of the executable, and build a memoization table on the intermediate results as well. And then we can have a demo like Blaine runs this, and then Zishan runs it, and it's way faster the second time, even though it's on a separate machine, right? And so we can do this kind of globalized memoization idea, and we think we can actually get there like pretty quickly. All of the complexity in IPVM comes around scale and trust and working in different languages. What's the ABI look like? So it's like all the detail work. The high level thing, I think we can actually show something relatively quickly. So I'm really excited to see what Blaine comes up with, hopefully for the next reactor.
Yeah, I think we should be able to get there. Yeah, for sure. Yeah, I was chuckling when you said that all the complexity comes from, and I was going to say the 75,000 papers that have been written about this.
Yes, yeah.
Yeah. Yeah, I think it's. I sort of have some hypotheses around, you know, like obviously there's lots of complexity when we get into the nitty gritty, and I look forward to having my brain broken repeatedly by Zishan and Brooke and Quinn and everyone else on this. But I think we can get quite a long way just having this sort of simple dumb implementation. It's a little bit like, I mean, I think the bash script pointer is a really interesting one, because bash scripts are really useful and are used for all sorts of things, and they're really like they're this ridiculously simple programming model, even though bash is kind of a terrible language. Like you know, you can do a lot with them. People do tons of super useful one-liners all over the place, and I mean, for the first 20 years of Unix, it's almost all we had at some level. Like, you know, CGI is like an extension of bash scripts to the web, right? Like they're these really, it's a really powerful metaphor. Yeah, it'll be interesting to see how much we can build just with that. So yeah, looking forward to digging in.
Awesome. Before I move over to the graph synchronization stuff, does anybody have, and we actually do run separate IPVM calls as well, but like, do people want to dig in on any of that stuff? Totally okay if not, but we'll leave space for it here too. All right, awesome. Zishan. We haven't gotten super far into this yet. For those who've been following our work for a little bit, we eventually got frustrated enough with BitSwap that said, you know, I think we know how we can make this faster and easier to work with. So BitSwap is a protocol baked into IPFS where you essentially do a bunch of round trips to ask for individual blocks. And as you discover deeper into a structure, you now know more things that you need to ask for, and you can just ask the entire network for this. And this is really great. It's very general and works nicely on a DHD, and doesn't give away any information about the state of your data store. But if we say, well, for cases where we're doing a lot of transfers between point to point, what if we could improve the speed of that? And so we spec'd out and are, I think, rounding out the first implementation of what we call car mirror using car files. That has a little bit more information between the requester and responder about each other's data stores, and so they can package things up to send in fewer requests. We have less latency going back and forth. We knew pretty much from the get-go, but then also talking to some of the other partners in the space, that they also want this to work multicast and bidirectionally. So we have a few thoughts on that, and actually, Marc-Antoine, the parity bitmap sketch paper that you sent along is the current hypothesis for how we're going to do synchronization between providers. So not the browser, right? This connection will still just be a regular Bloom filter, but between providers, I think it actually makes sense to do a PBS. And I know Zishan's done a bunch of looking at this kind of thing in the past, and actually has some thoughts like going down through different layers that we're probably not going to touch like immediately. But Zishan, do you want to talk a little bit about some of your early thoughts?
Yeah, obviously I'm still catching up to the world of, I mean, you know, we used to do a lot of work on Reactor with anti-entropy. I wrote a lot of that code for like how replicas keep each other in sync in the background. We use Bloom filters and these things like that. Obviously coming, the parity bit sketch stuff that's a little new to me. So looking at these optimized structures, some of the linear encoding stuff that you have been diving into, Brooke. So I'm still reading through that. But a lot of thinking in the carpool side is, you know, what is this variance of essentially multicast or something that looks like multicast? You know, to begin with, kind of maybe in a trusted set of players or groups. You know, you can imagine like the Protocol Labs trusted group that you talk to. Obviously, there are ways to do kind of ad hoc groupings and IPFS and swarm and all these things, but it's a little bit of a harder problem than thinking about it in an ad hoc way. But yeah, you know, what we're looking at right now is like, what are the most efficient structures to work across this kind of grouping of sharing information between client to group? I actually been doing a lot of reading just for GitHub issues of IPFS, where there's like one person, I forget their GitHub name, constantly talking about like multicast ideas and using Quick and using all these things to do things, and everyone just keeps closing that issue. So, you know, and relating it to like bit swaps, I think everything that you said, you know, before this about car mirror and that kind of plan, that now we're able to kind of rethink these things. So what does a multicast many to one variant kind of look like? And so what I'm exploring is essentially kind of going through like efficient data structures for sharing information. Of course, the parity, the bit sketch stuff, invertible Bloom filter stuff that Philip gave a talk on some time ago, but also kind of going back through some of the epidemic broadcast stuff, looking at things again like typical anti-entropy push-pull, but also things like rumor mongering and stuff like that. How do you want to have like background communication happen for these things for a cluster, for a group, you know, a designated group to actually communicate things in the background? What does that look like? How chatty that can be? I also have been re-looking at like, you know, I think you've mentioned this, Brooke, where eventually, you know, car mirror right now, we've been talking about the Go implementation, but could eventually be part of libp2p. I think there's something like that for carpool as well, because a lot of this stuff is interesting ideas around how to rethink, you know, the DHT and how those things work. I mean, one of the papers that was actually recommended to me as I've been going through this is, what was this? The pastry work, which is a lot about, you know, kind of P2P in the old tracker sense, but how to use oracles to try to convey information, try to speed up information. And so that's something I'm looking at as well. So yeah, that's kind of where we're going, obviously, in the research thing on this. You know, but how to actually try to, you know, do have a many-to-one relationship in sharing data. And I think this will also, you know, as if carpool works right for thinking about how to access data in a push-pull mechanism, it also can be a really interesting thing for thinking about compute and sending to a group, you know, essentially a cluster or group set of nodes. So.
Marc-Antoine, you had asked in the chats what we mean by multicast and like, or in this context, I guess. Part of it is So it's not that everybody has to have all the same information. It's how can I push data to, so I have a movie, it's 3 gigs, and I need all of that to be on these 3 server nodes from my browser to the server. Why I have 3 gigs in my browser, another question, but to these 3 server nodes, and I want to be able to stream that in parallel across to the 3 of them. But I know that those servers can also send bits to each other, right? So there's a version where we all end up with a file. There's another where it looks more like RAID striping, where it's like a third, right?
Thank you. That was exactly my question. I realize I lack a bit of background on what each project, sub-project scope is. You all know, you're within yourselves. And I'm like, okay, which part is carpool? What is it supposed to do? What is its scope? And which part is...
So that's a really great thing to raise, and somebody was also asking in the chat something similar. So and anyone else who wants to jump in, feel free. But basically, so the one that we've been mostly talking about, because most of the effort's been going into it, because Quinn was hired to initially start looking at the database, is Dialog, which is a CRDT, or it's a data log plus CRDTs, right? And it's kind of like multi-layered, this CRDT at the bottom, or is the data log at the bottom, right?
This part,
car mirror and car pool. So car files are essentially tar files, but with content address data. So TAR, CAR. And a lot of people have started adopting those in the IPFS ecosystem, because you can package up data into one file and send it, or you can open a stream and just append blocks to it, and it'll go point to point, right? The other nice thing is it doesn't depend on it. Also, I mean, BitSwap also doesn't depend on the DHT, but you can do a lot of things that are on like very lightweight clients that don't have full DHT access and all these things. Just say like, you know what, I just want a little HTTP library that I can push files around on. And so that works really nicely with a browser. Could we add a DHT in later? Absolutely. There's some concerns when so part of the idea, and I can add a video to this, or actually I think Justin's already dropping links in the chat. Part of the idea is I'm going to send to you some information about my data store, so you don't send me duplicate blocks as well. So if there's that 3 gig movie and I already have 2 gigs and you just change the credits at the end, I don't need the whole thing, right? That can potentially cause if I were to broadcast that to the entire world, there might be a security problem there, because I'm telling you a lot about the data that I have, right? So point to point, we're fairly comfortable with that. Doing with a trusted consortium, we're fairly comfortable with that. Getting this to be on totally untrusted nodes is an open question and an open problem that we will explore further down the line to recover total DHT goodness. Part of the idea here is, what if we had the major service providers inside of, and like, yes, totally peer-to-peer as well, but like the major service providers inside the IPFS ecosystem could all be, what if we striped it across these different services? Right? And so we could gossip with each other about, hey, I've got some bits that you might need, and you don't have to go to a DHT because I know everything that's in whoever, Pinata, right? Or an IPFS.io, you don't have to go to a DHT. You can always fall back to one, or maybe we add a DHT option in car mirror at some point, but today it's one hop and you're done, right? For whatever, 90% of data, right? So we can keep stuff off the DHT, make things faster, just kind of make them better for everybody, and cut down the number of round trips. So that's kind of the whole car pool project.
Thank you.
Third one is interplanetary VM, which is actually where Fission's been going from day one. But to do computation, you need to do data, including things like dialogue, right? And to do data in production, you need to do auth. So we essentially, it's not quite this clean, but we essentially did auth then data that compute. And I've dropped a video into the chat about that, because it's, on one hand, it's like, well, what if I just had a description of how to run computation? But there's a lot of detail in there around trust and effects and being able to memorize data and like a bunch of other things that are actually pretty interesting. that have been getting a lot of interest in the community, and we need to start experimenting and learning and figuring out what the right. I keep coming back to the ABI because that's my big open question currently. Like, what's the right interface for this thing, right? If you can write in any code in any LLVM language, right? Because it's WASM. Do we just adopt Z conventions? Like what's the right wrapper around that? And so we're talking to the folks doing the Filecoin VM, which is also in WebAssembly, and people doing WASM IPFS, which is replacing internals of IPFS with WASM, things like that, to learn as much as we can. And hopefully this is a highly applicable, I call it essentially the HTTP of compute. It's an open compute platform, right? Having a Lambda that anyone can plug into and be a provider in is kind of the idea. So.
Thank you for the grand overview. That's very useful.
Yeah. So we're not really working on too much here at the Fission Reactor. It's we're mostly just
details.
Drinking coffee. Yeah. Sorry.
Go ahead. No, go ahead.
Oh, I was going to hand it over to Quinn to talk about the dialogue internals that she wants to talk about, and the encryption. We had a big encryption breakthrough listening to Pink Floyd staring at the ceiling in Monterey. But it sounds like you had one more question, Marc-Antoine.
No, I'm curious to hear about the dialogue. The encryption granularity, that's something I worry about a lot, and I think Quinn is going there.
Yep. So Quinn.
Yeah, sure. I'll start with the encryption stuff. So let me share my screen. All right. Do you see my tablet by any chance? Awesome. So I have a list of tuples down the side here. I'm not showing the causality, but if you remember in dialogue, we are thinking of tuples as being these 4 tuples that have an entity, an attribute, a value, and any causal links that encode the provenance and what they depend on, and just all these relationships between facts. I didn't write out details here, so I'm just using placeholders, E0, A0, V0, etc. But I have a whole bunch of facts here, and an important thing to keep in mind in this case is that these different V0s are not necessarily the same. They're nested underneath their attributes. So with encryption and key sharing and so on, something that we care a lot about, like Marc-Antoine just mentioned, is this granularity about exactly how much you can share. And so something that we've wanted to be able to do is maintain the ability to share access to specific entities or specific attributes on entities or specific values on attributes, and to do so in a way that also allows you to share ranges of keys for the dataset. So you can share everything for a specific entity or everything for a range of attributes, for example. And so, yeah, I've got this example here. We've got 2 entities. They each have 3 different attributes on them. Most of those attributes just have 1 value, but then this attribute 2 here has 2 values on each of those. If we draw this out as a tree that makes the nesting explicit, we end up with this. Oops. So each entity has 3 attributes. Those have the values underneath them. But then kind of the big realization here is, and we were so close to this before, but if you look at this, it kind of looks like WinFS. And so we spent a long time trying to think about how to represent these tuple stores as essentially directories within WinFS, where different attributes correspond to different directories that themselves contain different values that would be files within those attributes. And that worked okay. It had a big problem to do with write amplification, because you'd be able to share access to specific attributes or values and so on with someone, but they would not easily be able to delegate or attenuate that access to someone else in a way that would subscribe them to any updates to that tuple store underneath the facts that they have access to. So we kind of went back to the drawing board. And what we ended up with, which is seeming very promising so far, is still drawing a lot of inspiration from WinFS, but from a different direction. In WinFS, we have something called the skip ratchet. If any of you were at Strange Loop, you may have seen Brooklyn's talk about it. The skip ratchet is, in a way, kind of like a fractal hash chain that we use for key agreement among different nodes. And what it allows you to do is like ratchet forward in time without ever being able to move backwards in a way that gives you post-compromise security and allows you to derive new keys from whichever ratchet state that you have access to, but without being able to access the states before it. And the way we represent that in WinFS is to basically have these different positions in the ratchet that correspond to different bases within like a positional number system. So you have like the ones digit, the tens digit, and the hundreds digit that represent different jumps across the key space that allows us to really efficiently walk across that key space to handle asynchronous key agreement for clients that may be offline for long periods of time. Within each of those positions, within WinFS, we have a bounded ratchet that kind of cascades to the next position and causes everything to like move forward in these giant jumps. But we realized that with dialogue, we can kind of riff off of that idea. And instead of having these bounded ratchets and these different components of the larger skip ratchet, we can have unbounded ratchets that each represent one of the levels of nesting within this tree that we have here. So that ends up looking a little bit like this, where we have this ratchet with three components, one of them corresponding to entities within the tree, one of them corresponding to attributes beneath that entity, and one of them corresponding to values beneath that attribute. And kind of the key insight here is that we can derive the seed for the attribute ratchet using the current state for the entity ratchet. And we can derive the seed for the value component using the current state of the attribute ratchet. And then by sharing different like permutations of this ratchet with people, we can share different subspaces of this key space. So as a concrete example, and I didn't get far enough to actually write this down while Zishan was going through his work. If we gave someone, for example, the ratchet corresponding to like 0, 1, and then X, where like 0, 1, and X are kind of placeholder values. And by this, I mean, they have access to everything within the third component underneath 0 and 1. That would give them access to V0 here, along with any other values that were written to attribute 1 of entity 0. So if that original writer who delegated those keys added more values, anyone with that ratchet would be able to derive the keys for those values and maintain access to them, but without being able to jump back up to get a key for attribute 2, or to jump back up further and get a key for entity 1. Where things get interesting, though, is that you can share enough state for them to reconstitute larger ranges of this key space. So if we give someone access to, for example, 1, and then let's say like X rooted at 1, with just nothing in this third component, then that would correspond to basically this section of the key space forward in time for that entity. So if new values are written to any of those attributes, or if new attributes are written, they would have access to those. Yeah, this just gives you a lot of flexibility in terms of how you break up the key space, how you delegate it. Anyone that you delegate these keys to can further attenuate those keys. So again, with this example here, if we give like 1x1 wildcard, that person can then delegate a new ratchet to someone else that's actually just like 110 to specifically share access to this tuple here. And really, you can slice things up any way you want here. And what this ends up looking like is on the client, you end up maintaining these different ratchet heads, basically corresponding to the different keys that you have access to. And then as you walk across the tuple store, you can use like the current head of each of the ratchets that you are looking at to figure out whether you have access to those tuples and decrypt them. We have a couple more thoughts about what exactly the data structure for this might look like in IPFS. And there's a couple of details that I'm glossing over to give us more control over like obscuring metadata about the sizes of different attributes and entities and so on, because we don't want attackers to be able to predict what different encrypted entities might map to based on the numbers of attributes they have and the number of values on each of those attributes. And we have solutions around that, but they're not super interesting to walk through here. Does that make sense? Am I missing anything important there, Brooklyn?
So I'll just keep going. An area that we're also looking at with this, I'll actually take one step back. So this is the encryption layout, which is separate from how it's actually serialized to disk or to IPFS, right? Which happens in 2 layers. And some of these insights come from us, like Philip and myself and Quinn and a few other people specifying WinFS in the Web Native File System Working Group. And then also having to put together some slides and explanations for things for some other folks, where in WinFS, there's your usual data and file semantic layers, but we also have encrypted, decrypted, and those don't stack. We originally thought that they would stack. They actually sit next to each other. And then you can kind of take like a slice across and say like, this is encrypted data, this is a decrypted file, right? And sort of mix and match them. So at this encrypted data layer, the layout will probably actually look like relatively like this, but probably slightly more sharded. One of the ideas we had was if we made, so it's going to go into the same data structure as WinFS, right? Because we can have, it's a pointer machine, we can have as many roots in there as we want, but we don't have to lay the data out like this, right? We can lay it out however we want as a pointer machine. So if we, for example, take the concatenated hash of the entity and attributes, we can store all of the values underneath that. And we don't need these multiple layers because there's no directory in here, right? We can just start writing those in. There's also a question about data locality. This is less well thought out at this point, but in WinFS, every version of a file will be in a completely, it'll look totally random, right? They'll be all over the place, but files are much bigger than tuples. And so if we want to get even a regular query, if we have to do 1,000 lookups separately into the data structure, that's probably not going to work when we're pulling the data down, right? And I'll get to what happens after that in a second. Because now we decrypt one layer and then we've got to go back in. Is there something new, right? All this stuff. So one idea is to, in WinFS, we have multi-values where if there's 2 concurrent writes, the same revision number of a file, they sit next to each other. And with this, maybe we take ranges of saying like, I don't know, 5 tuples for the same value will live next to each other. And then the next 5 will be in a completely different place. This probably, like, there's probably some things people could do to say like, well, I think these are probably tuples next to each other. And we're mainly exploring how we can hide that, or maybe keep the hashes close to each other, something like this, right? So it's not super well thought out yet, but we're exploring a few directions. When I said we pull this data down and then we dump it into our local store, essentially the pipeline here is encrypted data comes down, we decrypt it, we look at what it actually says, and then we can start building our local indices the rotations on because entity attribute value causality, if you want to do faster lookups, sometimes you want to flip those digits around, right? So that you can look things up by attribute, for example. So we can start building those local indices and so on and whatnot locally. And so those are at totally separate layers. There's like this ingestion step, and then you're in totally decrypted land where you can just read whatever and move around however you want. So it's really outside, inside. We've also been thinking a little bit about, and this is going to be kicking it back to Quinn to talk through, and also from some of the conversations at HPTS around the DBSP, so this differential data log idea, and how we can have use that to essentially GC the actual facts that we've already finished processing and only operate on the ones that are coming in. Quinn, do you want to talk a little bit about that as well? And then we can open up for questions. I realize we're throwing a lot at y'all.
Yeah, do you mean the Edelweiss stuff for that, or Edelweiss?
So I mean, we're reading Edelweiss in the next distributed systems reading group. We've been talking a little bit about if we can have this differential snapshot of a materialized view. Maybe we don't need to keep around all of the tuples, especially if we're on a low power device. Yeah.
Yeah. So that ties in heavily to Edelweiss, which is the next paper that we're reading for the distributed systems reading group. That is out of Neil Conway, who was a PhD student alongside Peter Alvaro, who wrote Daedalus. And the core idea behind Edelweiss is that if you have these event-based systems, like these event sourcing systems, where you keep track of every single event, and then you use data log to query over top of them, then because you're often joining across these different events under traditional systems, you need to keep track of all of the events that have come in so that you are able to correctly do those joins and so on as new events come in. Because they may rely on old stuff. But kind of the insight with Edelweiss, and that I think applies to us to a large degree, is that if you know what query you are going to be running over the incoming stream of events or facts, like we do with dialogue, then you can basically do data flow analysis over the query, which we are already doing because we are compiling down to data flow circuits to figure out which shapes of facts actually need to be kept for future computation. And they basically classify a couple different patterns around joins and anti-joins and things like that that describe which facts are safe to throw away, which ones are safe to keep, and so on. And under our model, I think that gives us a way to basically apply those same rules to the data log queries that we are writing and compiling down to these data flow circuits to prioritize which shapes of tuples are safe to delete, so that those can kind of be like that those can be the first things that we evit in the event that we're on a low power device or that we need to make more space. While still being able to, basically that. And is that kind of what you were getting at, Burke? I feel like I'm missing something.
I mean, that's a subset of what we've been talking about. So really, we're talking about a performance optimization, right, in space. So knowing what on a currently running query that we're materializing. So if we're in a Google Doc, for example, and we're typing away, we know that the materialized view will probably be sufficient. We're only going to stay in this little world here, right? But if we then start learning about, or the user then starts hitting other toggles and switches in the UI, and we start surfacing these other queries, or they pop into the console and start asking for stuff that we've already deleted, right? It would be good for us to know both, what have I seen before? Do I need to pull these facts down, et cetera? And it's always, we can always get back to as long as we're online, I'm going to go and pull this data back down again. And maybe we even know, okay, this fact tends to be associated with these other ones. I'm just going to grab those all at once, right? And pull these down together. So
Okay,
yeah, in the worst case scenario, we just run the query again remotely, pull the data down, ingest it, start building it up. And as it's streaming in, we're deleting stuff off the backside, right? If it's if we're on a really low power device, right, we have to keep things really tight. We can do that, but that's slower. So there's also this question, which we're also running into an IPVM of like, well, how much power does the current device have? And how do I tell it when to clean things up, right? Yeah. So
right, yeah.
all the stuff that Quinn was saying, absolutely, was kind of like a part of a bigger question.
Yeah, sorry, I misunderstood what you're asking about. And I guess the other piece of that is, and I guess the other piece of that is, in the past, we've talked a lot about being able to do like local time travel to move forward and back across your event stream. And like complete time travel from like the initial state to where you are now requires storing all of the events in the order that we observe them. But something that we are able to do to compact space, and this is something that differential data flow and DPSP do too, is maintain a low watermark for how far back you are allowed to walk across that event stream. And basically what that would look like is when we run out of space, we need to do garbage collection or whatever, we can garbage collect the oldest facts and compact them into a snapshot for whatever the like lowest upper bound is for the times that they were observed at. That'll give us basically indistinguishable view into everything at and before that point in time. So we can no longer time travel before that, but we can have this kind of like rolling window of the timeline that you're able to walk across that scales with the capabilities of the device that you're working from. So on a very low power device, that might mean not tracking any of that history and just materializing the current view. But if you're on like my MacBook, for example, that has like, I don't know, terabytes of RAM, you could keep track of every event and have that like time traveling element experience.
Yeah, and if you do need to keep, like in the scenario where keeping track of the exact order that things happen in across multiple sessions, and you know, like this large, long-running stream, you can do that because, as Mark Antoine rightly pointed out a couple months ago, this is a hypergraph, and we can write data about data very easily. And you could persist that. We just don't think that it's the best default behavior. Sorry, the hypergraph stuff is great. We don't think that keeping the stream around is the best default behavior for most people. Yeah. Oh, and actually rolling back quickly to the stuff I was saying before about this ingestion pipeline. The other thing to note is once it's in memory, we don't need to keep around the CIDs, the hashes of every tuple. We can turn them into, for example, REST pointers and have them just follow links directly, and then maintain a table that says, here's the CID, here's the pointer, or doing that at serialization time, because we can always get the CID back because it's deterministic. So, sorry. Quinn, I love how ahead of this, we're like, do we really have stuff to talk about? And here we are just like going on. So.
I think my standard for do we have stuff to talk about is do I have a demo of things working?
Which is a good bar.
But not the only one. Can I make a comment? Really excited about all I'm hearing about Edelweiss and how you're thinking about how to compute event disposability. That sounds brilliant, and thank you for that reference. And I'm so in favor of all I'm hearing on that part from that moment. The ratchet thing, very clever. You've lost me. Not in the sense that I don't understand, is that I don't think that this serves use cases I'm interested in. Now, of course, that's me, but I can see all cases where, for example, if I'm in a hypergraph, sorry, I am, I will want to, for example, restrict on the link. That means that the entity is in the V position, and I want to be able to make queries based on that. So the ratchet shape is very dependent. And I've made the argument before, and I'll make the argument again. You can use those Edelweiss subqueries or data flows, subflows as unit of encryption. I've said that many times. I won't occupy the thing with this now, but I do think that the tree here is almost misleading on the kinds of queries one might be interested in, or that I'm interested in. So that's my comment.
Yeah, absolutely. So there's nothing in here that actually prevents you from doing essentially what you're describing, right? It would require sharing more keys, is the difference.
Nope.
So,
well, maybe, not sure. But what I'm realizing, sorry, which I had not realized before, is that if you have an Edelweiss-like system with, what queries depends on another and so on, it will often be possible to say, oh, this query happens to include all the elements of that query, so I can just share that key and just give everything else on another key. So you can do kind of set difference and limit the number of keys that way. And a lot of keys will just be, oh, compound this one, this one, this one. I'll give those keys. Fine. And you're not creating a new key for the union whenever you have a union.
So I'm not positive that I'm understanding what you're saying, but my interpretation of what you're saying is that you share the keys based on the queries that are being computed over the data.
Absolutely correct.
And that, I think, is a very clever idea that works in more traditional deployments. But one of the issues that stands out to me here is that we're expecting first off the queries to be defined by the client and different between different clients, and second, to be over heterogeneous sets of data.
Yes.
So
I don't see that as an obstacle. It's a discussion we've had often. But I don't want to hijack beyond the point. I'm just saying I'm worried about this, that the kinds of, yes, you're saying it could be done another layer, but I'm saying that the shape of the encryption doesn't suit that. I think that layer matters and could be simpler, more useful, personally. Maybe wrong.
Yeah, so you're right if you assume that everybody's running the same queries, which we have as an anti-goal for the system.
It's no. If what I'm saying is, if not many people run the same queries, and those queries that don't fit can be composed in terms of known queries. So there's query reuse that will happen often enough. That's my. But no, I'm not assuming everybody's the same, using the same query. You create a new query, you create a new stream, which I'm sure is something that you're planning anyway.
Yeah, so we have all of the queries down at the client, right? So even the creator of the data doesn't know how people are going to query over it.
Yeah, that's the assumption. I'm not.
That's the piece that the skip ratchet fixes here, because the creator of the data can delegate a key to user A.
Yes, but that's possible.
Who can then attenuate it to user B, who can use it for entirely different purposes.
I think that's possible with my model. It's entirely possible for someone to be delegate. As long as you have this, you can create a subquery, a query subslice, if you will, for someone else. It doesn't have to be the creator.
Yeah, if you have live processes doing the redelegation, right?
If you, well, it's
so you need to run the subquery to build up that.
But that's where IPVM becomes useful.
Assuming that a service provider has access to the data.
No,
Yeah, absolutely. Yeah.
There has to be a live process somehow that has the high level query and can compute the restricted one, but it doesn't have to be one.
Mm-hmm.
And I think that's true also in any other model, right? It's you have to have access to the data. You have to have someone online who has access to the data.
So in our model, you don't have to be online, which is the
No,
innovation.
that's not true.
Right?
The data needs to be available.
The
but you
client
don't need
needs to be
any
online.
Compute.
What?
All you need is data availability through like
Yes.
IPFS, for example, but the client that delegated the keys doesn't need to be online to do any sub-delegations or attenuation in this model. It's all entirely offline. And what you're describing, I think, is very useful in under a different set of constraints that I think we will be able to capture on top of this system. But one of the big things that we're trying to do is avoid the online requirement entirely.
Actually, where I'm trying to be more flexible is I think the query doesn't have to live in the client. I think the owner of the data being aware of the queries is a plus and allows for amazing optimizations. And it also allows for an interesting business model in terms of subscriptions.
Yes, I agree with that. We've had a brief conversation about that before, and I think that there's a really interesting angle here, especially using like IPVM to have managed like indices and like key distribution and things like that.
Yeah.
Basically subscriptions, right?
Yeah. Mostly my reservations here is not wanting to bake any of that in as a requirement, but still wanting to support it on, still wanting to build a system that's able to support that on top of it.
That's understandable. Sodium asked, and that's a very interesting question, doesn't leak what you're querying. That's absolutely true. But I think it's also a way to be aware of what you're being queried on your own data, and it allows you more control over what you're allowing other people to ask you. So in terms of privacy, there's also a win in being aware of what you're being queried on.
I'm not actually sure if you end up with that control though, because if you're doing things based on query subsumption, then for any query that you offer up keys for, there is subqueries for the raw fat stream that someone could use to create a mirror of the index that they can share and support like generalized queries over, if I'm understanding you correctly.
Let me think about that one. That's interesting. I'm not convinced that you couldn't give the overall query without, no, not in the way I described it. That's worth thinking about. I think it's possible to do it so you only give the aggregate query result without giving access to the, like certainly you can do it with an intermediate, right? The intermediate has access to the subqueries, but yeah,
I definitely
right.
don't mean to dismiss the idea, because I do think that there's a lot of really good points in there. Just the online requirement worries me for the goals that we're targeting initially.
As I said, I don't think I have online requirement. I have query sharing requirement, which is a totally different set of requirements. But yeah, the other thing I worried about is, can we easily encrypt based on hypergraph queries? And with the ratchet thing, I don't see it. I found what was interesting in your model is X1 onwards on the attributes. So you have slices. I don't know if that extends to arbitrary sets, because then it requires a well ordering of the attributes by order of privacy, which is highly interesting as an idea, but I wonder how realistic that is.
Yeah, so that That's where the distinction here comes in between this like X1 and 1 case. And realistically, I think for most cases, you will just want to share ranges like at either the entity level or at the attribute level or at the value level if you're dealing with things like sharing my list of hobbies with someone and you would like them to have access to any additional hobbies that you add. But on the hypergraph case, I possibly have a solution here, but we haven't worked through it in detail. And this is something Brooke briefly touched upon earlier, but we didn't really dive into it too much. And that's that this ratchet idea doesn't actually depend on it being EAV. There's other structures that you can use for the ratchet that that follow a similar framework. And I'm not positive that this works, but the idea that's been bouncing around in my head is that if you're doing like hypergraphs, for example, sorry, go ahead.
So what I'm hearing is you'd have the SPO stream and the OPS stream and the PO stream and so on, right? Each
exactly, and like to make things more concrete, like if you wanted to have like a discovery fact store that attaches like attributes to it's basically like a schema registry. It's a bunch of schemas defining their attributes, and it associates to other entities that implement those schemas. That might be like a 5-level ratchet of like the schema and then the association and then the EAV underneath it for that entity that's associated to that schema. So you can share like a specific schema with someone, and then they will have access, they will be able to derive the keys for the like EAVs underneath each of those associations. And I think that this allows you to make like specialized key agreement schemes for some of the sorts of hypergraph use cases that you've talked about using a similar system, but it's still something that I need to workshop.
Okay. Yeah. Oh, I'd be glad to be in that conversation also, yeah.
You can also encode, and when I'm saying you can build it on top of the system, you can code exactly what you're describing in Datalog and have a hierarchical encryption directly in Datalog and say, here's links to keys, here's links to the next, to the successor, etc. Right? It just requires there being more keys being written down into the structure, because you have to track these keys are all under this one query, and these ones are under this other query. So you have to store more information. This you store almost nothing, right? Which is, the goal isn't a performance optimization. It's just like it's a nice thing that happens to fall out of it, where we share 1 or 2 32-byte numbers, and you have access to potentially the entire store, right?
Well, that's true also if you have a key for the whole store, right?
Or a sub, or some subquery inside, exactly. Or some subset inside of it, right?
Exactly.
Yeah.
What this gives you though is being able to break up the key space and doing that like temporal style sharing. Like I always use social media, but if you have like a decentralized social media site and you want to only share all of your posts with someone as of the point in time that you have befriended them, you don't want to leak all of that past information. You can just delegate them the key from that entity that's like the most recent in the store at that point, and not leak anything from before that point in time.
No, that's a really interesting, the temporal thing I see very well is extremely useful.
And that all happens again, like offline, without any coordination.
Though with the dependency graph of claim dependency, wouldn't you want to be able to go back along that axis? Like in a way to say, I'm sharing from there, and all the preceding claims, which is a
Mhm.
very different use
So-
case.
Yeah, so we started with that, and we actually couldn't get. There's two ways of looking at data in this model, and we're 10 minutes over, so we should probably maybe wrap soon. There's two ways of looking at data. One is essentially making a query and having it be sort of tabular or some aggregate, and the other is the causal links and the graph of data, right? In the graph case, you almost want access back along the path, and the tabular case, you want to segment, right?
You want the state.
Yeah. And so we tried to get them both working, and there was a lot of very what's the word I'm looking for, I guess, unintuitive things that happened in the graph case, where you would share this bit of data, and then suddenly you've actually shared all of this other stuff that seems unrelated, but is actually in the causal history. So the way that we handle that, at least in the current hypothesis, the current model, which could all change, right, is to say, if you want to give the entire causal history, you have to explicitly say, I'm sharing you these things.
Right.
Right.
Okay.
Yeah. And
Yeah,
so it's
yeah,
a forwards in
I
time
agree that
rather than
sharing
backwards.
history has to be explicit.
Yeah.
It has to be possible, but it has to be explicit.
Yeah, exactly. It's super tricky. It's super, super hard doing it this way.
Oh, yes.
Yeah.
Yes.
I think one of the programming models that will take a lot of getting used to, but that this sort of like local first data log based software enables, though, is, and this goes back to like the intersubjective software stuff, is this like idea of like truly progressive applications, where if I share like all of my posts from some point in time with you, but I do not share some of the things that they depend on, that your application will only be able to render the stuff that you have access to, and that's okay. What you have access to will work. It may not be the same view of the software that I have or that another person has, but it will be exactly what I give you access to and nothing more.
That makes perfect sense. Of course, queries are a way to specify the dependency, but enough.
Awesome. And we can keep the chat going in Discord or elsewhere, or even dive into this on a dedicated call if we so want. And actually, I don't know how I'm going to do this in the recording, but Marc-Antoine, I'm actually going to be in Montreal in a couple of weeks, so we should talk about that as well. Thanks everyone for coming. I'll post the video as soon as it's available. I'm going to turn the video off now in the screen recording.